In the summer of 2024, I sent an email and a worksheet to Dr. Robert Lopez, Professor Emeritus of Mathematics at Rose-Hulman Institute of Technology, and a Maple Fellow of Maplesoft on the topic of Monte Carlo numerical integration. With this worksheet, I sent him a sample problem of 3 overlapping circles. The problem was to solve for the area enclosed by these 3 overlapping circles. This problem inspired him to look for alternative ways, which he then presented in a video recently uploaded to the Maplesoft channel. In that video, he references my video. We both work on this problem, but get different answers. The question is, who is correct? And the answer is, we both are. How is this possible? Let's get started. We begin by looking at the problem that he worked on. It was based on an email that I had sent him the first time. I will leave a link to his video at the bottom. The problem consists of 1 large circle of radius 1 and 2 small circles of radius 1/2. The center of each small circle is at the edge of the large circle. From this time, Dr. Lopez derived, using both single variable calculus method and a flux through the enclosed area method, an exact solution for the area. The floating point approximation is, however, the area that I had calculated in my problem was this. And the reason why I got a different area is, not surprisingly, I worked on a different figure. Here is the image of the figure that I worked on. As you can see, it is rotated slightly, but there's one significant difference. The circle on the left-hand side is pushed further out. Traditionally, the Monte Carlo integration technique is demonstrated by solving for the area of a circle, but we already know what that answer is. So I wanted a figure which would require heaps of algebra and calculus. So the question becomes now, if I use the same code from before but apply it to the figure that Professor Lopez worked on, will I obtain the same floating point approximation that he did? And the answer is yes. So if you use the method 1 to solve for the area of this particular object, it requires 9 minutes on my computer and gets an answer of 4.0109, which is a 5-digit approximation to his exact answer. If we use the second technique, which includes defining all the variables by their type and making sure that we compile one important calculation, we reduce our calculation time to 10 seconds and we get essentially the same answer. And finally, if we apply the idea that all variables have to have a type and compile all the code, we can reduce our calculation down to less than a second, and again we get essentially the same answer. So for the same figure, all 3 approaches, the 2 that he used and the one that I used, gave essentially the same answers. His are more beautiful because they are exact answers. Mine is an approximation. Before I go, Professor Lopez, let me give you essentially the same 3-circle problem, slightly different. Please provide the area enclosed by these circles. All the information about these 3 circles is enclosed in this table.